Okay, so this is 2017 paper 2, question 5. So here you have, in a survey, the IQ scores of 1,200 people recorded, and the mean score was 100. So the mean score was 100. That always goes in the middle. And the standard deviation was 15. So that means that there's 15 less here. So you do 100 minus 15, which is why you have 85. 85 minus 15 is 70, and then 70 minus 15 is 55. So the standard deviations should be a difference of 15 each time, and then this is 15 added on. So that's why we should get 115 here, 130, and then 145. So assuming that IQ scores are normally distributed, the data are shown on the diagram. So this gives you 15 marks to fill in the empirical rule on the diagram. So a person is chosen at random from those surveyed using the empirical rule to find the probability that this person has an IQ score between 70 to 130. So you're looking at how many jumps that is away. So that's 2 away. And you can see that it's 130, so that's also 2 away. So that means that that's 2 standard deviations away from the mean. So if you think about how many away it is from the mean, so if it's 1 standard deviation away from the mean, that's where your 68% comes from. If it is 2 standard deviations away from the mean, that is where 95% comes from. And if it is 3 standard deviations away from the mean, it's 99.7. So 99.7 is if it is 3 standard deviations away from the mean. But because it's 2 away from the mean, that's 95%, and they want you to write it as a probability. So 95%. So the probability is equal to 0.95. So I'm just writing it as a decimal because probability is generally written as a decimal. For part 3 then, use the empirical rule to find the approximate number of people surveyed with an IQ score between 85 to 115. So from 85 to 115, you can see that that's 68% of the population. And they're asking you to find the approximate number of people. Well, you have to multiply that by how many people are in the data, and that's 1,200. So when you multiply them together, you get 816 people fall within that data. And for those 2 parts there, it is 5 marks. For part B then, the best thing to do here is I would just create a table because you've got a class of 24 pupils made up of boys and girls. Chemistry is studied by 6 of the boys and 9 of the girls. A pupil is chosen at random from the class. Find the probability that the pupil chosen is a boy or is a pupil who does not study chemistry. So here we're going to have boys and we're going to have girls and we're going to have our T for total. Then we're going to have chemistry, and then we have people who don't, so not. So, and then we have our total again. So just by creating a table, it just makes things a little bit easier. To fill in the information. So here we have a class of 24 pupils, so I put in 24 into the total. It's made up of 10 boys, so 10 boys and 14 girls. Chemistry is studied by 6 of the boys and 9 of the girls. So that means there's 15 who are studying chemistry. So meaning that 9 of them don't. It means that 6 boys don't study chemistry, and it means that 5 girls don't study chemistry. So they're asking you to find the probability that the pupil chosen is a boy. So we have a boy, so we have 10 out of 24. And then we have or is a pupil who does not study chemistry. So we have 9 of them who don't study chemistry. We already counted 4 of these boys, so we're just going to add the 5 out of 24, and that gives us 15 over 24. They're both divisible by 3, so that will give you 5 over 8. If you simplify it, that is worth 5 marks as well.